All right, forgot to take out the mic there. There we go. All right, here we go. Going to get right to it. There is a lot to get to, but I am going to go slow today here. We're going to try everything we just reviewed last week and had the quiz on. We're going to put it all together now. All right, so there was a reason why we did the 45-45 and the 30-60. There was a reason why we did SOHCAHTOA. All right, and it's to put this all together into these new concepts. I'm not going to badger you about this. All right, I got a 45-45-90 triangle. Hypotenuse length is 1, and I'm going to ask for the other two sides, but I won't put you through that, what the rules are again, because I know a lot of people hated that before the quiz. We'll just tell you here. Across from if this is 1 here, I would have to, everyone remember when we divided by radical 2? If I had the hypotenuse, I needed to divide by radical 2, get the radical 2 out of there. We all remember that glorious stuff, correct? All right, well, I'll do it for you. Across from the 45s is radical 2 over 2. And what's across from the other 45 then? Same thing, radical 2 over 2. Okay? And then in the 30-60-90, hypotenuse length is 1. I think most of you should be able to give me what's across from the 30. How do you go backwards? If I double it to go here, how do I go backwards? Divide it by 2. So guess what's across from the 30? 1/2. And I'll keep opening it up. What'd you have to do to the side across from 30 to get to the side across from 60? Multiply it by radical 3. All right, instead of saying 1/2 radical 3, here's how we're going to refer to it as radical 3 over 2 across from the 60. So again, across from the 30 is going to be 1/2, across from the 60, radical 3 over 2. Why do I put the number 1 on the hypotenuse? Why can't it be any other number? Here's why. Because from now on here, at least for this week, I'm going to be introducing it to you now, but we're going to be working in what's called the unit circle. Say hello to the unit circle up here. Why is it called the unit circle? Everyone see all of these here. What are these called in the circle? From the center to a point on the circle. What are these all called here? These are all radii, right? Unit circle, all the radii, 1 unit. Okay? So if you want to make a little mark here, this radius length is 1. Every radius is 1. Every radius is 1 up here in the unit circle. So I'm first going to start off by, can you give me what point is right here at 0? What is that XY pair? You can do it. I have faith. This goes out to 1. Think about this as your XY axis. It goes out to 1. What will that point be? What's that point on the x-axis? 1, 0. Yep. So at 0 degrees, that point will be 1, 0. Okay, all right. So now let's see, here's my goal right now. Can we go and fill out each point for all these degree measures on the XY axis? Let's start with 30. How long is this one right here? That's your length of 1. Everyone agree here? Length of 1. All right. So here's my 30. 30 degrees, that was a length of 1. Go back, look up above. What was across from the 30? Look above on your special right triangle now. What was across from the 30 degrees? 1/2, right? So should that 1/2, since it's going to be right here, is that going to be my y or my x coordinate? If this is 1/2 right here, which coordinate should this be going up and down here? Y or x? So my y coordinate at 30 is 1/2. And what's across from the 60? Look at your triangle. Look at your triangle, please. What was across from the 60? Here we go. Let's start here from 18. What was across from the 60? So that'll be my what coordinate now? X coordinate. So at 30, on the unit circle, the coordinate is radical 3 over 2, 1/2. All right, what about at 45? This one's always an easy one for people to remember. What's across from one of the 45s? Radical 2 over 2. What's across from the other 45? Radical 2 over 2. Guess what this coordinate is on the unit circle? Radical 2 over 2, comma, radical 2 over 2 on the unit circle. All right, what about at 60 degrees now? At 60. Well, what's across from 60? Look at your special right triangle we just set up. What's across from 60? Radical 3 over 2. And we said, ready, hey, across from here, that's my what coordinate? My y coordinate, radical 3 over 2. And guess what your x coordinate's going to be? What's across from the 30? 1/2. Can you go to 90 for me? I'm going to ask somebody what's the coordinate at 90. Remember, all those radii are how long? 1 unit. So I'm going up 1 unit right now. So what's the coordinate at 90 degrees on the unit circle? 90 degrees. Here you go, 18 again. What do you think the coordinate is up there, Hannah? Pretend this is an XY graph. Here's 1 right now. There's 1 on the y-axis. What's that coordinate? That was 1, 0. So this will be? Well, no. There's no 2's here because these are all 1. These are all a length of 1. So I'm going up to 1. So where would that be on the old graph? If you had this graph right here, this is 1. What's that point right there? This is 1, 0. So this will be 0. No, 0 is 8. 0, 0 is the origin, right? This point here, 0. 1 over 0, up 1, right? Yes? Everyone all right there? 0, 1. Can we just go right now? What's at 180? Go in this direction now. What's at 180 before I get to the other ones? What should be at 180? Here we go, 12. What should be at 180? -1, 0. Yep. And then go down to 270. What should be at 270? Here we go. 5. What should be at 270? 0, -1. All right, so we got those down. All right, go to 120 now. I don't have 120 on my special triangles above. You're darn right you don't. But you can still do this. All right, you can still do this. Here's why. Ready? 120. Let's start going back to reference angles again. Can anybody find the reference angle for 120 degrees for me? All right, 120 degrees. What's the reference angle? Matt, go. 60. 60. So this angle right here is 60. Haven't we done 60 before? Guess what this coordinate's going to be? 1/2 radical 3 over 2, but with a little change. Because what quadrant are we in? Second. Anybody know anything about the x coordinates in the second quadrant? They're all? Thank you. What about the y coordinates? They're positive. So there's the coordinate for 120. 135. Somebody find me the reference angle for 135 and watch this magic happen. Reference angle for 135. What's my reference angle? Here we go. 16. 45. Look at that. Do we already know the coordinate for 45? Radical 2 over 2, radical 2 over 2. Somebody adjust this for me because this is incorrect. X value is negative in the second quadrant. Yeah. Oh, 150. Guess what the reference angle is for 150? 30. Radical 3 over 2, 1/2. But which one do I make negative? The x. Got it. $210. I don't care that it's in a different quadrant. What's the reference angle for 210? How much is left here? 210. 30, right? So guess what the coordinate's going to be? Something with radical 3 over 2, 1/2. Anybody want to tell me about both the x and the y coordinate in quadrant 3? They both are negative. Keep going. Find the coordinate at 225, 240, 300, 315, 300. And we'll fly by them in about another minute and a half. Not going to do this for you. Let's try. Let's not stare. Let's go. This is part of the problem with some of you. We'll just let them do all the work. Okay, I'm going to get rolling. Let's go. 225. What do you got? What's the coordinate at 225 on the unit circle? 17. What do you got for me? Oh, no, great. How about 19? There we go. Yep, and got it. Let's keep going. How about at 240 now? 240. Here we go. 11, 240. Okay, let's step back. Ready? 240. Do we know how to find the reference angle for 240? It's 180. 240. What is the difference between 280 and 240? What is it? 60. So let's go to 60. What we labeled up there. What did we label as 60? 60? Radical 3 over 2. What quadrant are we in? And what do I know about the x and the y in both the third quadrant? Ready to move on to the fourth quadrant. Okay, let's go 300. 300. Here we go. 8. 300. 1/2 negative radical 3 over 2. All the y should be negative. 315. Let's go. 315. 17. Did it again. 8 again. 315. Got it. And then finally, how about 330? 330. Here we go. 9. 330. You got it. Negative 1/2. Perfect. Anything? We okay there? So, hey, bottom line here. Darn it, bottom line. How many do you have to really remember? 3. That's how many you have to really remember up here. Oh, sorry, getting crazy. And I just deleted that, probably, huh? Yep. Look at that. Deleted it. All right. You have to remember 3. 30, 60, 45. Those are the 3 you have to remember. We all in agreement? Then you just have to remember what's the reference angle and what quadrant. Can we handle 3 of them? And darn it, 45's what? The same numbers. So really, you have to remember two. 30 and 60, don't get the orders mixed up. That's what I'm asking you to remember. Can we handle that? Okay, now let's use those, and I'll show you how. This is state the quadrant, the angle's located, and then where would it be on the unit circle? Perfect. Here we go. 120. Draw your rotation diagram. This is review, nothing new. 120. What quadrant should I be in for negative 120? Go in the opposite direction. Quadrant 3. Yes, quadrant 3. So let's draw that rotation diagram in quadrant 3. Make sure you have an arrow going clockwise. Okay, what point would that go through on the unit circle? Find its reference angle. Try, and if you have to go back, I get it. All right, but I'm trying to have you guys not to just stare at the unit circle and get it. All right, what is the reference angle right here? That's 120 degrees. What is this reference angle right here? That's 60 degrees. Can we all, yes? Anybody want to see how 60 degrees? 180 minus 120. 180 minus 120, that's 60 degrees. So I start thinking in my head, what is the coordinate at 60 degrees on the unit circle? Is it 1/2, or does it start with radical 3/2? At 60 degrees, it starts with, okay, so I know it's going to be 1/2 radical 3/2, but you just got to pay attention to your darn signs. You're in the third quadrant. What do you know about the x and the y coordinates in the third quadrant? Here we go, 12. Both negative, so it should be negative 1/2, negative radical 3/2. We all good there? Okay, 495. 495. Go all the way around, that's 360. Another 90's 450. So it looks like I'm in what quadrant here, ladies and gentlemen? Second quadrant. And yes, make sure that rotational arrow goes all the way around. All right, reference angle. Can we get the reference angle from 495? And remember, I'm hoping today the reference angle you're going to tell me back is something of 30, 60, or 45, right? What is it for this one? 45? Everyone, 45 degrees? So I know at least now it'll be on the unit circle where? Radical 2/2, comma, radical 2/2, but which coordinate's negative in the second quadrant? The x one. Just got to remember the three of them. Pi/3. Is that going to keep rolling off our tongue? Pi/3. That was a classic one I had you guys remember. Pi/3. 60, 60, 60 degrees. Got it. Yep. This is 60 degrees. Pi/3. And that's just what point on the unit circle. Don't have to worry about signs. 60 degrees. Oh boy, yeah. We're going to have to get that down pat sooner or later because people are like, 1/2, radical 3/2. It's going to be 1/2. That is the only mistake that I can see happening here, is that you flip those for the wrong 30 or 60. Oh, got a little challenge here for you, kids. 3 pi/2. We could convert it, get out our reference sheets, and multiply it by 180 over pi. But here we go. Pi over 2. Pi over 2. Anybody? Pi over 2. 90 times 3. This is how many degrees? 270. Where is 270? Not in a quadrant. Not in a quadrant. And I want to start using this big vocabulary term. I should be harping on it more since I've shown it to you, but I have not been. So here's 270. Anybody remember what 270? It's called a quadrantal. Were you going to give me that, Anna? No, you weren't. No, be quiet. You weren't going to give me that. Quadrantal angle. It's called a quadrantal angle. Well, go ahead, Anna. Go ahead, though. Are you going to give me the point? Yeah. Okay, hold on. Everyone all right? 270 quadrantal angle. What point on the unit circle is it, Anna? 0, -1. Yep. Oh, calm down. Molly, how are we looking so far? Great, because you have no idea what's coming up next. Other questions? All right, so I threw a little 30, 60, 45, 45, 90 action at you. Now I'm going to throw a little SOHCAHTOA at you now. You don't have to write it down. I'll just keep it up here. Get fired up here. There we go. All right. Here's my right triangle. That's my angle I'm going from, theta, my acute angle. Can you guys find me what sine is equal to? Well, go. Use SOHCAHTOA for me. What's sine equal to? The what side over the what side? Opposite side over the hypotenuse side. Okay, I'm done. Opposite side over the hypotenuse side. Okay, every time I do that, it looks like the theta, and I don't want that. Okay, one last time. It's going to snap soon. 1 year, just going to take this entire board, lift it, and just toss it. How far it goes, I don't care. It'll just make me feel a lot less stressed out. Opposite over hypotenuse. All right, here we go. Sorry, I'm good. So I'm going right from theta. Name the side that's opposite theta in this diagram. Y over, and we're on the unit circle, so what's the hypotenuse length here? 1. Can anybody simplify that for me? Y over 1? Y. Oh, okay. So the sine is just equal to whatever the y coordinate was, huh? All right. Let's do the same for cosine now. Cosine. Now look at SOHCAHTOA. What side over what side? Adjacent over hypotenuse. All right, everyone with me right now? Going from that angle theta, what's adjacent? What side is labeled adjacent here? X coordinate. And still, because we're in the unit circle, what's the hypotenuse length? 1. Simplify that for me. Yeah. And here's what's probably coming up next in that big text box. The biggest thing I need you to know about this unit circle. Great that you know all the radii are 1. That's perfect. Here's the huge concept I need to sink in before you leave today and the rest of the week. When you are on the unit circle, any coordinate on there, the x coordinate represents the cosine of the angle. The y coordinate represents the sine of the angle. Okay, so again, one last time here before we move on. If we're on the unit circle, which we will always be on the unit circle for the most part this week, the y coordinate is the sine of the angle, and the x coordinate is the cosine of the angle. Probably doesn't mean much till we actually apply it, so let's do this. And that's what this text box is saying. X coordinate is cosine, Y coordinate is sine. All right. Using the unit circle diagram. So we're on the unit circle, everybody. 90 degrees. 90 degrees. Can anybody tell me what coordinate I'm at if I'm at 90 on the unit circle? Try not to look back if you can. Try not to look back. If I'm at 90 on the unit circle, what's that coordinate? Matt, what do you got? 0, 1. So the coordinate there is 0, 1. Everyone, we're all in agreement. 0, 1. And we're on the unit circle. So what is the sine of 90 without even typing it into your calculator? What coordinate represents sine? Again, look back if you need to. What coordinate represents sine? The y coordinate. What's the y coordinate right now in the unit circle? 1. Everyone go to your calculator right now and do sine of 90. Hopefully you're in degree mode. Anybody? Sine of 90? Boom! There you go. Cosine. We're on the unit circle. What coordinate represents cosine? The x. So what's my x coordinate right now? 0. If you want to go ahead, do cosine of 90 right now. And your calculator is going to give you 0 back. Amazing. Let's keep this going. What's the coordinate at 180? So I'm over here now on the unit circle. 90, 180. What's my coordinate at 180? -1, comma, 0. So what should be my sine? Which coordinate do I take for sine? X or y coordinate? What's that? Y coordinate. For cosine, which coordinate do I take? X coordinate. As long as it's on the unit circle, the sine is always the y, cosine is always the x. All right, can we finish this up? 270 now. 270, what coordinate are you at now at the bottom? 270, what's that coordinate? 0, -1, all right. So what's the sine of 270? -1, you can check it on your calculator. And what's the cosine of 270? Finally, where am I at for 360? 1, 0. I'm back at 0 again. 1, 0. So what is the sine of 360 without my calculator? I always pick the y coordinate, 0. And what's the cosine of 360? There we go. Okay, everybody good? Any issues with you guys so far? Okay. Quickly go through these because we can just use the box here again. Sine of 2x. What are they asking me to f of what here? What are they asking me to plug in here? What's that symbol? They're asking me to plug in y. Pi. Everyone, pi. So they're asking me the sine of 2 pi. 2 pi, anybody? 2 pi? That's radians for what? Anybody remember that one? Pi is 180. 2 pi is 360. Yes, so they're really asking me what's the sine of 360. And we can use the table. It's already there, so I'm not going to force you to go back to the unit circle. Sine of 360, 0. Okay. Pi over 2, part B, pi over 2. That's 90. Cosine of 90. Is that a plus or a minus, guys? Plus 2 times the sine of 0. Cosine 90. Okay, it's already there. Plus 2 times sine of 0. 0 and what are the same here? 360. So you're right. 2 times 0. And that's just going to give me 0 again. Are they all going to come out to be 0? Let's find out. Part C. -2 cosine 180. -1 plus 3 times sine of 270. Sine of 270. -1. And that'll end up being 2 plus -3, -1. Yep. And look, I'll be honest with you. I'm not going to sugarcoat this. I'll be honest. You always use your calculator too. All right, if you ever forget sine of 180, cosine, I'm not going to force you to use the unit circle. All right, you could use your calculator. Unlike this one here, this is when I wrap it all up, and this becomes awesome right now. Be on your toes. All right, be on your toes. Find the, all right, first of all, directions. Exact value. And this isn't really mathematical of me to say this, but this means no sloppy decimals. All right, no sloppy decimals. So if you go, and you can just do it right now. Go ahead, sine of 30 in your calculator. That's what it's asking me first. What's it come out to be? 0.5. That's, I don't want it. How could I change that real quick into a fraction? 1/2. Okay, I could have forced you to use the unit circle, but I'm not going to go into here because you could just use your calculator. All right, but now do the sine of 45, everybody. That is what I refer to as a sloppy decimal that I do not want. I want it in some kind of fraction radical form. And your calculator doesn't convert it, sorry, into that. All right, so here's where we're going to go back to the unit circle. Ready? Let's tie this darn thing together today. 45 degrees. What is the coordinate at 45 degrees on the unit circle? Radical 2, and I don't want you to, you can if you want, I guess, but it's what? Radical 2 over 2, comma, radical 2 over 2. Everyone in agreement? But I'm looking for the sine. The sine. What coordinate do I, and it doesn't matter here, but what coordinate do I pick off to find the sine of an angle? The y coordinate. So out of those two, you can't go wrong, I know, but out of those two, what's my y coordinate? Radical 2 over 2. So guess what the sine of 45 is? An exact value, radical 2 over 2. And if you type that into your calculator, you will get that same 0.707 sloppy decimal back. Radical 2 over 2. Questions? Cosine of 30. Nope. Sloppy decimal in my calculator. Cosine of 30. All right, so go to your unit circle. What's the coordinate of 30 degrees on the unit circle? All right, here we go. Coordinate of 30. 18. Coordinate of 30. If I'm finding cosine, guys, which coordinate do I want that represents cosine on the unit circle? X coordinate. And what's the x coordinate here? Radical 3 over 2. Tonight you're just, I know I got one more, but tonight you're just sticking in the first quadrant. Tomorrow is what happens when I go to the second quadrant. And not much, it's just the sign changes. All right, we got one more, right? Okay. All right, this should be hopefully a quick one. Let's see. Let's find out. Ooh, terminal angle. Anybody that one? Gamma, beta? No, not beta. Gamma, maybe? Alpha? Good talk. All right, drawn in standard position. It goes through this point, negative 0.6, 0.8, which lies where? Where's this point? On the unit circle. On the unit circle. And I'm looking for what's the sine of that angle. It's on the unit circle, and I'm looking for sine. What coordinate am I focusing on? What coordinate am I focusing on? I'm on the unit circle, and I'm looking for sine. What coordinate am I looking for? 1? The y coordinate. What's the y coordinate? We're done. Nothing fancy here, guys. If I'm on the unit circle, the y is the sine, the x is the cosine. Go ahead, turn it over, get going as much as you can get done here.